Welcome to Tech Unplugged. Today we're diving deep into the crucial world of cloud security risk assessment and frameworks, specifically tailored for you, the curious learner who wants to grasp the essentials without getting, bogged down in all the technical details. We've gathered some really fascinating insights today. We'll be looking at how to figure out the potential downsides of using cloud services, different ways major cloud companies approach security, and even some proactive steps you can take to protect your cloud environment. Our goal here is really to unpack this information so you come away feeling knowledgeable and maybe with some real aha moments about navigating cloud security.
Yeah, it's a super important area. And to start, let's think about the very foundation. Assessing risk when you work with a cloud service provider is sometimes called an SP. When the company providing the infrastructure, the IP, negotiates something like a service level agreement or SLA, well, both sides need to understand what could go wrong. For you as the infrastructure provider, let's say, this risk assessment builds confidence that your important assets, your data, will be safe, just like the SLA promises.
Right, so it's about understanding what you're getting into before you even sign on the dotted line. And this risk assessment, based on your specific needs, it can look at a few different things, can it? It's not just about hackers or security breaches.
Exactly. Security risks are definitely a big part of it, yeah. But the assessment can also cover legal risks, like
Well,
data privacy rules, regulations. Then there's the risk of the actual physical hardware failing, the servers themselves, and even the risk of the virtual machines, the VMs that your services run on encountering problems. So the overall risk of, like, saying yes to an SLA request is really seen as a combination of all these potential issues.
okay, so it's like looking at all the individual pieces that could potentially cause trouble. And one way to get a better handle on this, more detailed risk, is through quantitative risk analysis. Now, that sounds a bit technical, but the core idea is actually pretty straightforward, isn't it?
It is. What's interesting here is that in quantitative risk analysis, we define risk by looking at two things. Basically, how likely is something bad to happen? And what would be the impact, the consequence, if it actually did? This lets you prioritize your efforts based on something measurable, helping you focus resources where they really matter, instead of just sort of guessing at threats.
That makes a lot of sense. So it's not just a vague feeling of, oh, this is risky. You're actually trying to put some numbers to it. And this involves identifying those potential events, figuring out how probable they are. Then you estimate the level of risk tied to those specific parts, the VMs, the physical hosts, the SLA itself, and ultimately you as the infrastructure provider.
Precisely. You start by looking at those individual risks tied to specific events, maybe a known software vulnerability or some kind of potential cyber threat, and you calculate the risk for each one. And then these individual risks get aggregated.
Yeah, they get added together, basically. It's like, think of each potential problem, a weak password, a software bug, as maybe a single drop of water. Individually, maybe not a huge deal, but when they all collect, they can become a flood that overwhelms your system. That's kind of what risk aggregation helps you see the potential for lots of smaller issues to combine into one big one.
That's a really good analogy. And the approach we're discussing really emphasizes that just assessing risk at the start isn't enough. You
Yeah.
need to continuously monitor risk by watching how your computing resources are behaving within the cloud provider's environment. It also highlights how crucial it is to have interfaces, ways for independent third parties to audit and check your security measures.
So it's not a one and done checkup. It has to be ongoing monitoring. And the focus here seems to be on threats that might originate within the system itself, things that could disrupt your services. This monitoring uses both historical data, what's happened before, and real-time information, what's happening right now from the cloud infrastructure.
It's exactly right. This kind of continuous monitoring is absolutely vital for a robust security strategy. It allows for both proactive measures, things you do to prevent problems, and reactive measures, how you respond when things do go wrong. And this applies across the board. Physical hardware, VMs, SLAs, the whole infrastructure level.
There's an accompanying image that really illustrates this idea of risk monitoring over time. You can see these different lines tracking risk levels, physical host risk, virtual machine risk, SLA risk, and the overall infrastructure provider risk. What really stands out is how these lines fluctuate. They move up and down.
Yeah, what's fascinating is just how dynamic these risk levels are. They aren't static. They're constantly changing. You can see periods where, say, the VM risk level might be trending upwards. That could indicate growing threats or maybe some configuration drift in that area. And conversely, downward trends might suggest that your security controls are actually working, that your mitigation efforts are effective. It really drives home the point that cloud security isn't something you just set up once and forget. It demands constant attention and adaptation.
Okay, I think we've got a good handle on the basics of cloud risk assessment now. Let's shift gears a bit and look at how a major player, Amazon Web Services, AWS, approaches this with their security reference architecture, the SRA. Think of the AWS SRA as like a guide that's always evolving.
That's a great way to put it. It's not some static rule book, it's really a living set of best practices. It gets updated pretty regularly to include new AWS services and features, feedback they get from customers, and crucially, to address the always changing threat landscape. So it's constantly trying to keep pace.
And its main purpose, the SRA's goal, is to help users effectively use all those different AWS security services together, right? Like a common question might be how to best connect a service like AWS Config, which tracks configurations, with other tools to automate security checks and monitoring pipelines.
And that's exactly the kind of thing the SRA helps with. It provides guidance on how different AWS security services rely on each other, how they support each other to create a more cohesive and, frankly, stronger security setup.
One of the key recommendations we see in the AWS SRA is using AWS Control Tower. Could you maybe explain Control Tower? It sounds like a way to quickly set up and manage a multi-account AWS environment. Why is having multiple accounts so important?
Right. Control Tower lets you implement pre-built security controls, or guardrails, right from the start when you set up your AWS environment. It essentially gives you a blueprint for key security functions like identity management, federated access, setting up centralized logging, and having standard ways to provision new accounts. Think of it like building a ship with watertight compartments. If one area gets breached, the damage is contained, right? It doesn't sink the whole ship. That isolation is a huge benefit of the multi-account strategy.
And you're not just stuck with the defaults. You can customize these accounts further. It mentions something called customizations for AWS Control Tower, or CFCT.
Exactly. CSCT lets you layer on additional, more specific security controls and governance policies on top of the accounts that Control Tower sets up and manages. And the AWS SRA actually provides code examples in its repository showing how you might implement these kinds of customizations.
So the SRA really stresses building on a solid foundation, and this foundation seems to rest on two main pillars. That multi-account strategy we just talked about, and putting strong rules in place for managing who can access what the identity and access management, or IAM guardrails.
That's spot on. These guardrails are absolutely essential for implementing fundamental security principles. Things like least privilege, meaning people only get the permissions they absolutely need to do their jobs, nothing more. And also separation of duties, making sure no single person has too much control or access.
Let's dive a bit deeper into this multi-account idea.
Yeah.
Why is spreading things out across different AWS accounts generally better than just having one big account for everything?
Well, like we touched on, an AWS account provides really crucial boundaries for security, for access control, and even for billing. It gives you resource independence and isolation. Using multiple accounts lets you logically separate your different workloads, maybe based on their function or specific compliance requirements like PCI DSS for credit cards or IPO for health data, or even just based on needing similar security controls.
So you're creating these logical walls, these compartments within your cloud environment. And the advice seems to be, even if you start small with just one account, you should plan to move towards multiple accounts as your needs grow and things get more complex.
Yeah, that's definitely the recommended best practice. And AWS Organizations is the service that helps you manage all these accounts centrally. It even has a neat feature called Delegated Administrator. What's the advantage there?
From what I gather, it lets you designate specific accounts within your organization member accounts to manage certain AWS services across all your accounts. So this gives different teams, like maybe a dedicated security team, the flexibility to manage the tools and services relevant to their responsibilities without needing full admin rights everywhere.
Exactly. It promotes that separation of duties principle again. And many security-related services in AWS support this delegation model. We're talking about AWS IAM Identity Center for Identities, AWS Config, AWS Firewall Manager, Amazon GuardDuty for threat detection, and lots of others. Often, a dedicated security tooling account is designated for this purpose to manage these central security services.
And then at the overall organization level, AWS provides tools for governance and control across all accounts. Service control policies, SCPs, are one example.
Right. SCPs act like high-level guardrails for your entire organization. They define the maximum permissions available. So even if an administrator in a specific account tries to grant a permission, if it's blocked by an SCP at the organizational level, it won't work. It's like a safety net.
And then there's AWS CloudTrail. You can set that up for the whole organization too, right? Not just individual accounts.
Yes, exactly. An organization trail in CloudTrail captures a record of pretty much all the API calls and actions made across all the accounts within your AWS organization. This gives you that single, comprehensive audit log, which is really powerful for security monitoring and compliance, much better than trying to piece together logs from individual accounts.
An AWS Firewall Manager allows central management of things like web application firewalls across all those accounts.
Mhm.
The diagram we looked at, labeled organization, it really helps visualize this, showing the root, then organizational units, or OUS for security, infrastructure, workloads.
Absolutely. You can clearly see how that security OU contains the critical accounts like the security tooling account and the log archive account, emphasizing their central roles. And then the workloads OU holds the individual application accounts where the actual apps live. It makes the structure quite clear.
Okay, let's talk about controlling who can do what within AWS. The information mentions identity-based policies in IAM.
Right. These are the core policies. They get attached to IAM identities. That could be a user, a group of users, or a role that an AWS service assumes. And they explicitly define what actions that identity is allowed or denied to perform on which resources.
And there are also session policies. How are those different?
Session policies are interesting. They are passed as parameters when someone or something programmatically assumes an IAM role. They provide temporary, often more restrictive permissions just for that specific session. So think of the identity policy on the role as the maximum permissions, and the session policy can only further restrict those permissions for that temporary session. It adds another layer of fine-grained control.
And for managing user access, especially single sign-on across all these accounts, there's AWS IAM Identity Center.
Yes, that's the recommended way to handle workforce identity. It integrates with AWS organizations and lets you manage user identities and their permissions across all your AWS accounts centrally. You can connect to your existing identity provider like Azure AD or Okta, or use its own built-in directory.
We mentioned AWS Config earlier, but its role in continuous monitoring seems really critical for security posture.
Absolutely critical. AWS Config constantly tracks how your AWS resources are configured. It records changes and can evaluate those configurations against desired rules. It's invaluable for detecting configuration drift, ensuring compliance, and spotting potential security weaknesses caused by misconfigurations, which are actually a very common source of breaches.
What about keeping network traffic private and secure? AWS Private Link comes up.
Private link. Yeah, that allows you to establish secure, private connectivity between your VPCs, those isolated virtual networks, other AWS services, and even your own on-premises applications. The key thing is that the traffic doesn't traverse the public internet. It stays on the AWS private network backbone. It's great for client-server setups or when dealing with things like overlapping IP addresses between networks.
Okay, shifting to application deployment. Many people use Amazon CloudFront as a CDN, a content delivery network. What are the key security considerations there?
Well, a major one is using AWS WAF, the Web Application Firewall, with CloudFront to protect against common web exploits and bots. Now, you have some choices on how you deploy WAF with CloudFront. You could manage it centrally from your security account, which gives you consistency, or you could deploy it within individual application accounts. This gives the app teams more control over their specific rules, but it might impact your overall service quotas for WAF rules.
And restricting direct access to the origin, like an S3 bucket.
Yes, that's crucial. You don't want people bypassing CloudFront. Origin Access Identity, OAI, was the older way, but the newer, more flexible method is Origin Access Control, OAC. Both basically ensure that only CloudFront can fetch content from your S3 origin bucket, forcing traffic through CloudFront, where your WAF rules and other security controls can be applied.
Got it. The diagram showing AWS security services and features for AWS principals really drives home how central IAM is. And the shared services account diagram illustrates that centralized management for things like Security Hub, GuardDuty, Macie, Config.
And the OU security diagram adds more detail, showing Firewall Manager in there and the central logs account aggregating logs. It paints a picture of that centralized security model.
And even if perimeter services like WAF are deployed in the individual application accounts, it sounds like Firewall Manager still offers central oversight.
It does. Firewall Manager allows a central security team to enforce a baseline set of WAF rules across all accounts, even if the application teams add their own specific rules on top. Plus, centralizing the AWS WAF logs into the security tooling account gives that organization-wide visibility, while still allowing application teams to see their own logs and dashboards.
Okay, circling back to identity management, AWS offers both centralized models, like IAM Identity Center, and delegated models.
Yeah, the goal is always ensuring the right identities, whether they're workforce users, applications, or even end customers, have the right access to the right resources under the right conditions. That's the core principle.
And for workforce access, IAM Identity Center is the top recommendation.
Correct. Because it integrates well with AWS organizations and can connect to existing identity sources or manage users directly.
What about federation? If a company already has, say, Okta or something similar, managing logins.
IAM Federation is designed for that. It lets you establish trust between your external identity provider, IDP, and your AWS environment. A common pattern described is setting up separate trust relationships for each AWS account. This provides a distributed approach where roles and policies might be managed closer to the accounts they apply to while still leveraging the central IDP for authentication.
Makes sense. When dealing with EC2 instances, those virtual servers, best practices like using AWS CloudFormation for instance profiles are mentioned.
Yeah, using infrastructure as code tools like CloudFormation to apply instance profiles programmatically during creation ensures consistency and avoids manual configuration errors. And using VPC endpoints provides private, secure connections to supported AWS services like S3 or DynamoDB without needing internet gateways or NAT devices, enhancing security.
For applications needing AWS credentials without a human involved, Amazon Cognito has a feature called the Client Credentials Grant.
That's right. It's a standard OAuth 2.0 flow that allows applications or services to authenticate themselves securely and obtain temporary AWS credentials. It's much safer than embedding long-term access keys in code.
And Cognito itself can also be used as a full-blown customer identity and access management service, right, for managing your end users.
Yes, absolutely. Cognito can manage user directories, handle sign-up and sign-in, support multi-factor authentication, and federate with social identity providers like Google or Facebook, as well as enterprise providers using SAML or OpenID Connect.
Okay, let's touch on generative AI, specifically Amazon Bedrock security. What are the key concerns there?
Well, you need to think about securing access to invoke the models, obviously, but also securing the conversation history, any prompt stores you might use, and encrypting all that data. Monitoring for risks like prompt injection, where someone tries to trick the model with malicious input, is also important. Bedrock itself provides controls for data protection, access control using IAM, network security, logging, and input-output validation.
And Amazon Macie can help find sensitive data related to AI, like in prompt stores.
Yes, Macie uses machine learning to discover and classify sensitive data in S3, which could include data in your prompt store or model invocation logs if you're storing them there. It helps you understand where your sensitive data related to Gen AI might reside.
Encryption seems really fundamental here, too.
Absolutely. Encrypting data at rest using AWS KMS keys and data in transit is crucial for Bedrock. If your knowledge base uses Secrets Manager for credentials, those secrets should also be encrypted.
And applying least privilege when creating IAM roles for Bedrock agents is stressed again.
Always, give those agents only the minimum permissions they need to function. Don't grant overly broad access.
An AWS IAM Access Analyzer can help identify those overly permissive policies.
It can. Access Analyzer helps you refine permissions by analyzing access paths based on your policies, identifying potential external or cross-account access, and highlighting unused permissions. It helps you achieve least privilege without solely relying on analyzing logs.
The AWS Cloud Adoption Framework, the CAF, is mentioned as providing a phased approach to cloud transformation. Where does security fit in?
Security is a core perspective in the CAF, woven throughout the journey, but it gets particular focus during the launch and scale phases as you build and expand your cloud environment. And the AWS SRA we've been discussing aligns directly with the security design principles of the AWS well-architected framework, helping you establish that secure baseline architecture recommended by the CAF.
Centralized logging in a dedicated log archive account comes up again as a key best practice from the SRA.
It's a cornerstone practice. Having all your logs, CloudTrail, VPC flow logs, application logs, etc., securely stored in one immutable place is vital for analysis and auditing. Tools like CloudWatch Logs Insights, Amazon Athena for querying S3 data, and Amazon OpenSearch service can then be used to search and analyze these logs. Amazon Security Lake can even further centralize security data from various AWS and third-party sources into a data lake format.
And managing services like GuardDuty and Security Hub across the whole organization.
Features like guard duty organization and security hub organization, using that delegated administrator pattern we talked about, often in the security tooling account, allow you to manage these services centrally. This gives you a single pane of glass, a cross-account view of security findings, threat detections, and compliance status across your entire AWS estate.
Right. And finally, it mentions a whole suite of other AWS security services contributing to a robust posture. Shield for DDoS, WF for web apps, Firewall Manager, Systems Manager for patching and config management, VPC for network isolation. It's quite comprehensive.
It really is. Putting it all together, our deep dive shows pretty clearly that a structured, thoughtful approach to risk assessment and security architecture is absolutely paramount in the cloud. Understanding that shared responsibility model, knowing what you're responsible for versus the cloud provider, is critical. Leveraging the security services and frameworks offered by providers like AWS, like the SRA, can massively enhance your security posture. Implementing those core principles, least privilege, strong IAM, encryption everywhere, continuous monitoring, these are foundational. And finally, you just have to remember that cloud security is dynamic. The threats change, the services change, so ongoing vigilance and adaptation are absolutely key.
Okay, so let's unpack what this all means for you, the listener. Whether you're just starting your journey in the cloud or maybe looking to refine your existing security practices, really understanding these core concepts of risk assessment and security frameworks is essential. We've seen how frameworks like the AWS SRA provide incredibly valuable guidance, and how combining proactive measures with continuous monitoring can help you navigate the sometimes daunting complexities of cloud security. Thank you for listening to Tech Unplugged. We hope this deep dive has given you some valuable insights. Stay tuned for more explorations into the world of technology.